For homework that's due on Tuesday, that's tomorrow, we have worksheet 1.5. That's this one right here. It's based on Descartes' rule of sign. I told you right the first time. I second guessed myself, but I was right the first time on when you have some type of polynomial, doesn't matter what type. Let's say that this is your problem. Let's say that's the problem that I have, right? The idea is on this polynomial, when you first start, you don't need to fill in the zeros. I was really hesitant because it says it has to be in descending order, so I'm like, all right, descending order is greatest to smallest. And then I noticed that every problem in the book always had every term. Well, this one doesn't, right? It's missing that x to the fourth term. You don't need to fill them in. You don't need to put zeros, because I kind of looked at other textbooks that I had. I had a bunch in the back, and I looked online at some different ones. And I was trying to find an example where they would be missing terms and still do Descartes' rule assigned to it. And every example I found, they always had every term. There was never one that had a missing term. Until I found a certain website, I think it was like Berkeley's college website, and they had a calculator there that some students had put together where you could type in a function, it would tell you, how many positive roots, how many negative roots it potentially has. And sure enough, when you actually look at this and you count, and it says, it switched once, twice, they actually just went with that. So they actually, it didn't matter. It would have been different, if there was negatives and other things. So it actually considered, positives. They didn't fill in these zeros and whatnot. So I was pretty happy that, I pointed in the right direction the first time. My instincts were right. So, but yeah, so that was what we talked about on Friday last week, is how to find that Descartes' rule of sign, where you count how many times it sign switches, and then you go down by twos if that number is pretty big, and you see how many positive roots there are, or negative roots, and all that good stuff. Today, we're going to do a few different notes today. That's what we're going to cover. We're going to cover a few topics today, and hopefully you can kind of get a sense for what we're going into. There's just kind of some weird topics we have to talk about, some different things. So I wanted to give you a chance to kind of look at some different types of problems here. So let's do a quick example here right in the beginning of stuff we've previously done, and then I'm going to type to the new stuff today, and I think that's kind of important. So, all right, so here's the example I'd like you to write down. I'm just going to stick with something kind of easier, I guess. Let's see, I had it written down. Where's my examples at? Where if I put my notebook? Oh, I bet I did. Okay, so this is going to be our one example here. I want to just kind of cover it. Plus x squared plus 2x minus 48. And we're going to divide this all by x squared plus x minus 6. All right. This is going to be kind of our general topic today. This is something we did previously, so this is kind of our review. This is long division, right? There's a couple different ways you can do this problem. That's what I want to clean up today, different ways of approaching this problem. So one way to do this, if you're doing a polynomial divided by another polynomial, is you just put them in the house. You do that old school long division method where, the item in the front of the division sign, that old colons. This is the dividend. It goes in the house. And then the item on the back behind the division sign, that's the divisor, and that's the item you put over here. Okay. And then you decide to long divide, right? So what we talked about previously is how you long divide, and this is something we did early last week, I believe. We did long division. You had to figure out, okay, what do you multiply on an x squared that gives me x to the third? X, right? We multiply by a 1x. I'm going to put it back here. The reason why I'm putting it back there is I always like to line up what you're multiplying by above what it kind of matches. It matches x's. I know it doesn't really matter. I always do this. I know it's kind of weird and particular how I do it. I just always like to line it up above the right letter so I know where I'm at. So I'm going to multiply by a 1x. So when I multiply by a 1x, I get 1x cubed, that's 1x times x. 1x times x is 1x squared, and 1x times a negative 6 is negative 6x. If that makes any sense when I multiply. Now, what do I have to do next? Subtract straight down, okay? So we subtract, so we switch all the signs. And that was something I never really talked about last week. What happens when you have a negative number? You know, well, you have to switch it, right? And then you just go straight down. 1 minus 1, that's 0. 9 minus 1, that's 8x squares. 2 plus 6, because it is actually a positive 6, so 2 plus 6, which is 8x, and then you bring down the next item. Does that make sense how we did last week's stuff? And then we start all over again. We start with the whole process. So now we figure out, again, same thing, I'll switch up colors here. What do we multiply on an x squared to make 8x squared? 8, positive 8. So I'm going to multiply by a positive 8 because I need it to match perfectly. So if I multiply this by 8, I get 8x squared, perfect. That's what I want it to match without going over. 8 times x, that's 8x. And 8 times a negative 6, that's negative 48. And we switch the signs and you go straight down. So if I switch the signs, negative, negative, positive, everything makes 0, and that's what we want. We want that remainder to be 0. That means it works out perfectly. It's an actual root. That's great, fine and dandy. Your final answer is x plus 8, and that's what we talked about last week. Okay, now, I'll let you write that down. That's great. What does it also mean? That's something else. Well, since we found that the remainder is 0, that means it's a perfect factor, right? It went into it perfectly. It means it's an x, potentially x-intercept. If you could factor this apart, these would be the roots, because they work, right? But also, this is also a root, and that's what we talked about on the worksheet we had earlier last week. When you long divide things out, the item that is left on the top of the radical sign, on top of the division sign, I should say, that's also a root. So x plus 8, I know I had a 1 in front of it, doesn't matter. There's a 1 in front of x. What does that represent as an x-intercept? Negative 8, okay? And then the other item that we just divided out, this thing, obviously it worked. We divided it out. It worked out to be perfect. So if we factor this thing apart, those are the other roots, because I actually checked them. It's, what is this? It's plus minus, it's x and x, because I have to break up the x in the back. Now, how do you break up 6? 3 and 2, and yeah, so 3 and 2, that'll make the 1 in the middle, 3 and negative 2. So then these are my other roots, so it's negative 3 and positive 2. Now, why did I bring this problem up? The whole point of doing this is to find roots, right? To find x-intercepts, that's what we've been doing. Why I brought this problem up in particular is I checked 2 of them at the same time. I checked 2. If I knew 2 numbers worked, because think about back to that worksheet we did last week. We had to list out potential roots to a problem, and you and your neighbor used a calculator and you were like searching frantically until you found one or ones that worked. Well, let's say you and your partner were double teaming a problem and you're taking, let's say this is my original problem, right? And you were going through and you were listing all the roots that worked for this problem, and you were trying positive numbers and your neighbor was trying negative numbers, and you stumbled upon a positive number 2 worked. Like you typed it in and went, oh wow, 0 gave me 0, 2 gave me a 0, so it worked. And you're about to tell your neighbor, and your neighbor goes, hey, I just found one too. I just found that negative 3 worked. Well, you just found 2 at the same time, right? So what you could have done is if you found 2 at the same time, you could have multiplied them together, like this, and then divide them all at the same time. So you didn't have to waste as much work. You didn't have to divide later. You knew that both of them worked, so if you multiply them together, this should also work, the product of them. And sure enough, it did. And you'd have been left with the third one, because you knew that this one should have 3 roots to begin with. That's one strategy you can do. Now, another way you could have done this problem. If you set it up in a fraction form, and you could actually factor this thing apart, right? And I was checking to see if this worked. If you knew how to factor the trinomial on the top, which we didn't, I made this problem up so you couldn't, but you knew it was going to be this, let's see, what was it? Plus 3, and it was x plus 8. Okay, and you could actually factor, let's say you have the skills to do that, and you factor it apart, and this is what you're dividing by. You factored this thing apart, and this ended up being x plus 3, x minus 2. You could cross these out, and you'd figure out the other one that would work. Because that was something you did in Algebra 2 days. Okay, you could do those, they call it the rule of division, the law of division, that you can cancel things out if they're all products. That's not practical because we couldn't factor that thing in the first place. So, there is this other way of dividing. This is great. This works, like long division works every time. It's my preferred method. I know that seems weird. I like long division. It works out pretty. It works out for any type of radical whatsoever, or any type of long division, I should say. Anything that you want to divide, it works for any size polynomials. It's great. There is another type of division, which, in fact, you guys actually brought up last week, and it's in this section that we're moving into, section 1.6. It's called synthetic division. And I said division, not substitution. And I was surprised that you guys saw this in Algebra 2 a little bit, at least some of you remembered it. It's a different type of division. It doesn't look like this. It's different. It's just this weird, quicker way of long dividing that some of you could remember, which I was really surprised by. I want to walk through that today, and then I'm going to show you its shortcomings. It's like why I always choose the long divide versus doing synthetic. The synthetic is faster. It is. But I want to show you that today. Okay? So I'm going to do an example of synthetic so you can see it. I'll do it for this problem so you can see I get the same answers. We're going to work with this problem. So cubed plus 9x squared plus 2x minus 48. All right, and I'm going to divide by x, plus 8. Let's just do that one. All right. So this is synthetic division. It's something it's a different type of division. It gives you roots. It checks for other answers. What do you notice I'm dividing by in this one? What is that item that I'm dividing by? Why did I choose that versus this up here? What's the difference in the item I'm dividing by, the divisor? What type of polynomial is it? Binomial. When you do synthetic division, you can only divide by binomials. First degree binomials, nothing with an x squared or anything like that. It's got to be a first degree. Your highest degree can only be a 1. That's the only thing you can synthetic divide by. In fact, there's other rules. You can't synthetic divide by anything that has a leading coefficient, in fact. So if there's a number out front, there's a number out here, we have to actually get rid of it. So there's actually more challenging rules, and that's what we're going to look at probably tomorrow. But today was just kind of an intro day to show you how it works. So I got a couple of problems picked out that we'll try. Okay, so let's just walk through the process. So how synthetic division works. It's this weird little quirky rule. It's this little item that somebody put together so it's really compact and it will actually divide your items. You have a number up in this house. There's this little box up in the corner. We'll put a number up there. And then you're going to have a bunch of terms going across along the top. They're just going to be numbers. Just digits are going to be sitting out here. And then you're going to put a bar underneath it. That's what it looks like. That's like the setup that we're going to have, okay, for synthetic. And then I'll explain the rules here. So now, the number that goes in this box, it is the root you are checking to see what works. So what number am I actually checking divide out of this thing? Yeah, say it. -8. I'm checking a -8. Notice it's the opposite of the binomial. So the x plus 8 represents the number -8. That's the number that's in the box. Okay? So that's the number that goes right there. It's a warrior. I do. Sure, we'll do. Yep, bye. Okay. Right here. Hold it. See you later. If you want, I can send you a link if you want to watch the video later. Okay, all right. So I have that -8 sitting in the little box. Now, what are the numbers going across the top row? So the numbers that go up here, they are the leading numbers of the dividend. And if there's any missing terms, you do have to fill in zeros. I know that for a fact. So what's the leading number out front? 1. You put that here. No variables after it, just the 1. The number that's after it? 9. The number after that? 2. And the last number? -48. Okay, if there's any missing terms, you have to fill in zeros. That's the same thing with long division. If I was missing anything in long division, you do have to fill in zeros before you long divide them. So if there's any missing terms, we'll look at more examples of those tomorrow. Maybe one of our challenging problems we'll look at. Okay, does everyone understand the setup? The dividend is all those leading numbers. That's the numbers in blue there, or the numbers in the back. The number in the box is the thing you're checking. It's the root you are checking to see that works. So maybe you and your partner were doing a problem, and you're like, oh, hey, I found -8 works. You can go synthetic divide it out, because you found 1 that worked. Just 1, it's a binomial. Okay, is everyone ready to go? Okay, all right, so here's how it works. You drop the first number straight down. So that 1 repeats, okay? Now, this is the start of the process. You will always multiply by the number in the box. So you're going to take this number that you just dropped, and you're going to multiply by the number in the box. So 1 times the -8, and you get -8. Again, you multiply by the number in the box. That's how I get that number. Okay, does everyone understand the first few steps there? Drop, multiply by the number in the box. Now, you are going to add straight down. You can't just drop it down right now, so you have to add. What is 9 minus 8 when you add straight down? 1, okay? Does everyone see that? You add straight down. Now, again, just like before, you will multiply by the number in the box. So if I multiply by the number in the box, 1 times a -8, I get -8. And you will add straight down. So 2 and a -8, that makes -6. So you're adding straight down. What do you think I'm going to do again? Multiply by the number in the box. So -6 times -8, that's positive 48, because negative times a negative is positive. You add straight down and voila. And yes, I put a dashed line in the back. The back number, now it's a 0, right? That back number. Put a dash in front of it. That number is the remainder if you were to long divide. This is the remainder in the back. So it's telling me, by just knowing this number, that this number, the number you checked, the root you're checking for, my -8, actually did work. And the item that's left, right here, that's in front of the remainder, this item here, is the reduced function. It's the rest of the roots. Now, this is the tough part. This is the part that, it's not the setup and it's not the process of going straight down, multiplying by the box, going straight down. It's writing the final answer down and knowing what that means. So, what was your highest degree earlier? 3. You will always go down by 1. You always go down by 1 because we're taking 1x off. That's what you're doing. You're dividing 1x off. So when you take 1x off, I'll be left with x squared. So this first item is 1x squared. It's always 1 less power. So if this original function was like x to the 5th, then you'd have x to the 4th sitting there. It's always 1 less power. And then the next item, you just count down. So this will be 1x, and then this will be the constant in the back. And then the remainder I don't care about. That's just in the back. Don't want it. Okay, does that make sense? That item, since you know the remainder was 0, this item is the rest of the roots. Well, duh, that was what I just wrote earlier, right there. It's the same problem. I just wrote a different one. All right, questions. Okay, now tomorrow we're going to look at a problem where I put a number out front. So I'm going to put a digit right here, and we're going to see the complexity of it. We'll see how difficult that actually gets. So I'll pick a problem that will have a leading number out front. We'll make it pretty challenging. So, okay, questions with synthetic right now? Okay, let's do another one. Let's do one more. And I'll just kind of make up a problem here and we'll just kind of try it out. And then this will be one of the last problems today. That's all I want to talk about today. Just want to intro our section that we're going into. And then I'll give you some time, or if you have to work on your worksheet, the 1.5 that's due tomorrow, you can do that. It's the Descartes rule of sign worksheet. It's due tomorrow. I know a lot of you have already turned in. I'll go through the list of who's already got it turned in today too. And you guys are kind of relaxing. All right. Let's kind of go through let's go through a number. I'm going to make up a problem here. Sorry, it's going to get kind of ugly. We're going to go with x to the 6th plus 2x to the 4th minus 3x plus 10. And we're going to divide this by x plus 2. Now, what are my options? What could I do on this problem? Synthetic, because I'm dividing by a normal polynomial, right? A binomial. So I could do synthetic, which I am going to do that. It's probably the easier method. It's faster. I could do what else?
Long division.
I could do long division. If I could factor that monster apart up top, I could, in theory, I could do this problem by just, cancel a rule, the law of division. I can't factor that thing. To me, that's non-factorable. Maybe if this was like maybe if this was 3 and a, maybe if this was if this was like a 6 and a 10 or something, maybe I could factor out numbers, or 6 and 20. I could possibly pull out numbers where we could get it to look the same, but they're not going to. All right, so we're going to do the x plus 2 here. We're going to use synthetic. So what does this represent as a factor? -2. That's the number that's going to be in your box. The number right there. That's the number we're checking to see if it works. And then the number is going across the top. It is your leading coefficients on the dividend. And if there's any missing terms, you have to fill in zeros. So, leading number out front. 1x to the 6th, right? Then it's 0x to the 5th, 2x to the 4th, 0x to the 3rd, 0x squared, -3x, and a positive 10. Does that make sense when I filled in my zeros? 0x to the 5th, I had 2x to the 4th, no x to the 3rd, no x squared, and a -3 and a 10. If you forget to fill in the zeros, it will cause problems. So just keep that in mind. Okay, now, let's walk through the math here. So what do we do in the beginning? Say it again? Yeah, you drop down the first number. Then you multiply by the number in the box. Okay, so I'm going to multiply by the number in the box. -2 times 1 is -2. You add straight down, you get -2. So again, you multiply by the number in the box, you add straight down. Now what do I do again? Multiply by the number in the box. So -2 times 2, that's 4, positive 4. And I'll add straight down. So we get 6. Right, add straight down. You multiply by the number in the box. That's -12. You add straight down. I can already tell you it's probably not going to be 0. I can already kind of see what's happening here. But we'll keep going. Maybe it does. We're going to multiply by the number in the box. That's positive 24. You're going to add straight down. You're going to multiply by the number in the box. So it's -48. You had to multiply by -2. You're going to add straight down, that's -51. You multiply by the number in the box, it's -102, or positive 102, I should say, positive 102. You'll add straight down, and we got a remainder of 112. So that's my remainder. So this did not work out pretty. I don't need to factor it, I don't need to do anything, it's not going to work, so that's probably not a good number. So maybe your neighbor, when they said it worked, maybe they forgot to type in a negative sign, so maybe you want to go check +2. Maybe they forgot, maybe they wrote it down wrong, if they were trying long division or synthetic, or they did substitution, maybe they plugged in a number in the wrong spot, they had a wrong power on something. But what this represents x to the 5th, x to the 4th, x to the third, x squared, x, and then the 51 is the constant, and then this is the remainder. The remainder is always over what you divided by. That's how you always write remainders. It's always what you divide by. It's divided by an x plus 2. So it didn't work on isoprene. We didn't get a 0 in the back. That's how you write remainders if you ever have one. So whatever the remainder is over the top. That's how you actually write mixed numbers, by the way. So whatever the remainder is, it goes over what you divided by. That's how you write mixed numbers. A lot of people don't know that. Okay, questions? Okay, I'm gonna stop there. It'll be about 15 minutes today to work. Worksheet 5.1. This is the, or sorry, 5.1, 1.5. That's your departure rule of sign. This is due tomorrow. Keep that in mind. You don't need to fill in any zeros for doing that. So just make sure you're setting up the charts. That's really all I want to see. You get done, finished, complete. I'll take it. All the good stuff. You're done, finished for the day. So.